Hello everybody, welcome to lesson 3 of chapter 5 on solving trig equations. Before I start that, I got a joke for you. Obviously, you guys know that we have a brand new soccer stadium in Minneapolis, and my question for you is, what lights up a soccer stadium? Answer is a soccer match. Get it? A soccer match? Fire? All right. To solve trig equations, we'll start with a very simple one. Cosine of x equals 1/2. If you look on the unit circle, there is answers to this. Since it's cosine of x equals 1/2, you're going to look for x values on the unit circle that equal 1/2, and that would be 60 degrees. There would be another answer at 300 degrees. But there is infinitely other solutions besides 60 and 300. If you look at this graph, this is a graph of a cosine wave and a horizontal line at 1/2. And so you can see that we have a solution right here at 60 degrees, another one at 300. We'd have another one at 60 plus 360, or 420. We'd have another one at 300 plus 360, or 660, and there'd be many more solutions. So we're going to solve problems like this. The directions simply ask us to solve it. And what we want to do is get like terms together. So here's a like term and here's a like term. So I'm going to move this 2 sine of x over by subtracting. That would give me 2 sine of x equals the square root of 2. If I divide both sides by 2, I get the square root of 2 over 2. And now I go to the unit circle to get my solution. And since this is a sine function, we look for y values of root 2 over 2, and that would be at 45 degrees. And there'd be another one at 135 degrees. But because there's an infinite number of solutions, we have to put a plus 360n on the end of each of these, because that's going to give you additional answers outside of the unit circle from 0 to 360. Next example again just says solve. We've got 2 terms on the left, 1 term on the right. Well, I've got a couple of like terms, so I'm going to move the tangent of x over here, take the negative square root of 3 and move it to that side. And that's going to give me the tangent of x equals positive square root of 3. If we now look on the unit circle for that value, it should be 60 degrees. We're going to put a plus 180n on the end of that. Why do you suppose it's 180n instead of 360n like we had on this problem? Because the period of a tangent function is 180, not 360. The last problem was involved with sines. And this would give us all of our answers. We could have an additional answer of 240 plus 180n. But if you think about it, let's put 1 into the expression that I've got circled here. So 1 times 180 is 180. 180 plus 60 gives us the 240. So really, the second expression is not necessary, even though tangent equals the square root of 3 at 2 locations on the unit circle, that being 60 and 240. Here's another example. What's different about this one is we've got a trig function squared. I'm going to subtract 1, divide by 4 to get the sine squared of x by itself, and that would give us 3/4. Now I square root both sides, and once I square root, I got to use a plus or minus, and then we'd have the square root of 3 over 2 after square rooting the right-hand side. So if we look at the unit circle, we're looking for y values equal to square root of 3 over 2, and that would be at 60 degrees. And it would also be at 120 degrees. And then we'd look for the sine value of negative root 3 over 2, and that'd be at 240 degrees. And also at 300 degrees. So we got 4 expressions that would satisfy this problem. If we wanted to try to rewrite that answer in a more efficient manner, we could say 60 plus 180n along with a 120 plus 180n. So the answer in green produces the same answers as the answer in black. Next time we've got a cotangent. So again, we want to get that cotangent squared by itself, so I'm going to subtract 4, divide by 3. That's going to give me cotangent squared equals 1. Now anytime you have a cotangent, you want to reciprocate and change it into a tangent. So we've now got tangent squared of x on the left. which means I need to reciprocate the right-hand side, and the reciprocal of 1 is just 1. Now I square up both sides, and that gives me plus or minus 1. And so now we go to the unit circle, and tangent equals 1 at 45 degrees. And tangent equals negative 1 at 135. So two separate expressions for all of our solutions there. Well, now the last couple of examples that I have, the directions are slightly different. It says to find all solutions to the equations on the interval from 0 to 2 pi. So this time we don't have to use the plus 360n, and instead of being in degrees, our answer is going to be in radians. So if you look at this problem, we got one term on the left, we got one term on the right. I'm going to get everything on to one side, so cosine of x times the sine of x minus 3 cosine of x would equal 0. Now I'm going to try to factor, and you can see that I can factor a cosine of x out, leaving me with sine of x minus 3. Now we set each factor equal to 0, and in doing that, we get cosine of x equals 0, we get sine of x equals 3. Now if we look on the unit circle, cosine equals 0 at half pi, and also at 3 pi over 2, so there's two of our solutions. And the sine never equals 3, and so we'd have no solution to that part of the problem. In fact, if you were to type in sine inverse of 3, you can see you get an error. And the reason you get an error is because if you were to graph this, here's a simple sine function. And if I put a horizontal line at 3, and if I just adjust my window to show that, you can see here's our sine wave, here's the horizontal line at 3. The blue line would never cross the red line. Next example, very similar to the last. We've got one term on the left, one term on the right. We're finding solutions between 0 and 2 pi. So I move everything to one side. And after I move everything to one side, I'd want to factor a cosine of x out. It would leave me with 2 sine of x minus the square root of 2. Now we set each factor equal to 0. So cosine of x would equal 0, and the sine of x would equal positive root 2 over 2. Now we go to the unit circle to find our angles. And cosine equals 0 at half pi and 3 pi over 2. And sine of x equals root 2 over 2 at pi over 4, and also at 3 pi over 4. Last problem I want to go over with you. This problem, again, solving between 0 and 2 pi, gets solved similar to a quadratic equation, a problem that you might see in Algebra 2. So I want you guys to think of this as m to the 4th plus m to the 2nd minus 2 equals 0. If you were in Algebra 2 and factoring to solve this, you would set an m squared at the beginning of both factors. Then you'd put a plus 2 on one of these factors and a minus 1 on the other, because those two numbers multiply to give us the negative 2, and they'd add up to give us the positive 1. Even though you don't see a 1 in front of that m squared, there's a 1 there. And so now you'd set each factor equal to 0. We're going to do the same thing, but we've got cosines. So I'm going to factor this into cosine squared minus 1, cosine squared plus 2. Setting each factor equal to 0, we'd get cosine squared equals 1. Square up both sides, we get plus or minus 1. Cosine equals 1 at 0, and cosine equals negative 1 at pi. So there's the two solutions from that factor. If we set cosine squared equal to negative 2, square up both sides, we get the square root of negative 2, which is an imaginary number, and cosine never equals an imaginary number. So, again, lesson 5.3 is on solving trig equations. You have to use your unit circle, and you have to typically do some factoring and use some algebra combining like terms.